Hello and welcome to the latest episode of the Modern Brewer podcast with me, your host, Chris Lewington. So I'm back after a bit of a winter break. I hope you all had a great festive period, however you decided to spend it. I took a bit of time out, kind of thought, who wants to record a podcast over Christmas, etc. So I took a bit of break, but I'm back now. It's actually an episode and a mini series, but just 2 episodes of something I've been wanting to do for ages. I definitely have a passion project to try eliminate purchased CO2 from craft breweries in the UK and Europe. And the reason is we've all seen it, right? So because it's a byproduct fertilizer production, we're getting huge supply shocks. People saying, oh no, you can't have any CO2 for 2, 3, 4, 5 weeks. Price increases of 3,000%. I can't, even saying those numbers, sometimes you say them in passing at conferences and stuff, and it doesn't quite sink in until you start thinking how ludicrous a 3,000% price increase is on something that is essential to your brewing process. And I feel that some of the gas companies, I'm not going to name names, but they're taking advantage of that shortage and they're forcing contracts on people. And I find that whole side of the industry is something that we can definitely eliminate. And I actually predict in 5 to 10 years, no brewery will purchase CO2 anymore. And the reason I believe that is because there's 2 technologies available to brewers that eliminates at least 85, 95, maybe even 100% of your purchased CO2. And those 2 technologies are CO2 recapture and nitrogen generation. So the mini-series is going to be a kind of in-depth dive into both CO2 recapture and nitrogen generation. This week's episode is going to be on nitrogen generation, and I think I've got a really cool angle for how this is going to work, and I think it's going to resonate really well with everyone, all the brewers who are listening and anyone else. But before we get into the episode, I'd just like to mention some upcoming events that I will actually be attending and speaking, and it would be really great to see you guys there. And the first 3, which sounds like a lot because it probably is, are actually some really cool, they're called Bootcamps or Murphy's Grain to Glass. So it's Murphy & Sons, the supplier, and these are UK events, and they're sort of all day, and they're going to take you through very in-depth on the sort of brewing science, and especially obviously surrounding brewing aids treatments, mashing, mash pHs, kettle finings, auxiliary findings. It's the stuff that you use, but you will come out learning exactly how to use it, how to optimize it, why it works, and what to do when it doesn't. So it's really valuable information. I attended one back in 3 Locks. I can't remember the date, but it was a really good event. And I'll be honest, I sat there going, damn, I really should have known that. So I actually also somehow got a speaking slot at the end. So a complete curveball at the end of all of this is I talk about my company, Brew Resourceful, and more, to be honest, more about how a brewery can become more resourceful and reduce their waste. So I do that nice little 30 minutes at the end, but I get to attend the rest of the day. I'll give you the 3 dates. The first one is at Castle Rock Brewery. It's on the 6th of Feb in 2024. The second is actually a brewery is quite close to my heart because the neighbors are the first brewery that I ever worked in. So that's Rooster's Brewery on the 13th of Feb in 2024. And the third is Wiper and True, the 20th of February 2024. So they're the 3 events. I'll link in the notes the Eventbrite. So I think the first one available is Castle Rock. If you're interested in any of them, just hit up your Murphy's rep. I don't know what the fee is, but I'm sure it's on there on the Eventbrite. But it's well worth it. It's super educated, and I guarantee you'd leave it with something. I think it's well worth it. And of course, the big one in the UK brewing calendar is coming up with Beer X in Liverpool. So I will be speaking with Steph from Murphy's as well on stage there. Great to catch you guys. If anyone's listening to the podcast regularly, it'd be great to meet you in real life. So yeah, I wanted this episode to have both an educational aspect of what nitrogen generation is combined with a real life example of nitrogen generation working in a brewery. So today's going to be a live episode. You might already be able to hear some of the background noises of a brewery. And this is going to be quite unique because we're going to have one of the sales reps, of course, with us. And actually we're going to have someone who has a real life example, working example, and it's going to help the listener understand how to transfer CO2 over to nitrogen. So I'm really excited for this episode, and joining me today is going to be Craig Smith of Pneumatech and Alex Redpath of Full Circle. And welcome to the show, Alex and Craig.
Afternoon.
Afternoon, yeah.
Yeah, thank you guys for joining me here in the wonderful Full Circle Brewery. You might pick up some background noise from the brewery. For me, it's quite satisfying, so I hope it is for you as well. Maybe we can just kick off. Alex, you want to introduce yourself and then followed by Craig?
Yeah, hi, I'm Alex. I'm the head brewer at Full Circle. I've been here from day one since we opened up, helped develop the site, pick the equipment, develop the recipes, and now more concentrating on efficiencies and making sure the product's as good as we can.
Yep, and I'm Craig Smith. I'm the business development manager for Pneumatech in the UK and Ireland. I've been with Pneumatech about 3 years now, but involved in compressed air and nitrogen generation for almost 10 years now.
Excellent. And that's a Scottish accent for those European listeners. All right, so yeah, let's talk about nitrogen generation. Let's get everyone on the same level as always. So Craig, maybe you can spend a bit of time just explaining what is nitrogen generation, how it works, and what are kind of the options to do it.
Yeah, absolutely. So, as the name suggests, of course, generating your own nitrogen, used in the brewing industry as an alternative to CO2, just for the avoidance of oxygen, also used in a wide range of other food and beverage industries. So effectively, we take compressed air and we filter out the 20 odd percent of oxygen, depending on the required purity of gas. And yeah, there's a wide range of systems in terms of size, output, purities, etc. But there's two different types of technology: pressure swing absorption and membrane technology. So as I say, there's a wide range. The kind of overarching benefit, there's two main ones, is the cost reduction versus either liquid or bottled gas, which is delivered by a third party, and then of course the sustainability side of it as well. Generating your own nitrogen has a huge sustainability impact and a reduction in your carbon footprint.
Awesome. So for Pneumatech and other people, what makes you decide whether you do swing or membrane?
So the purity is a factor. The pressure swing absorption goes all the way up to 99 points, so that's the same level of purity that medical and pharmaceutical require, and the membrane has a limit of about 99.5% purity. So a few factors, be it flow, space availability, these sorts of things, lead us to which technology is more favourable for the customer.
Yeah, I think we will touch later on what sort of purity we would be looking for in the brewing industry, but generally I think 99.5 is considered plenty for the brewing industry.
Yeah, it's what I was looking for when we were, it's kind of the minimum that I was looking for when we were starting out.
Did you play with the sort of pressure swing absorption idea?
Our kit was purely based on the size and the flow more than anything else. So once we matched that up, it gave us an idea of which piece of hardware suited us and then what purity was available on that hardware.
Yeah, absolutely. So, I mean, it's interesting that nitrogen gets talked about. I mean, I talked about CO2 in the intro, but I mean, the big positives of nitrogen is it can actually be generated on site. It doesn't have a negative impact on the environment as a gas compared to CO2, and it mainly, probably the most important thing, doesn't react with caustic in a negative way. So it's quite an interesting gas to replace the majority of CO2 in the brewery with. But of course, probably the biggest difference is that it's significantly lighter than air and oxygen. So as a purging gas, it's not perfect compared to, or they're not comparable compared to CO2. So a great question for you, Alex, and one that I hear a lot, and one I would love to have answered is, how much of the CO2 in your brewery have you been able to switch to nitrogen? And, what areas specifically have you maybe had trouble with, or maybe found it really easy, and how did you actually do that?
Okay, so I'll probably just go through what we originally used CO2 for, and then what we swapped out for nitrogen. So we would use CO2 for head pressure on tanks. We would use it for pressure transfers from fermenter to bright tank. We would use it to carbonate, purging vessels, purging cans on the canning line. We don't have our own kind of keg cleaning system, but if we did, I'm guessing we would have used CO2 on that as well. We've managed to swap out nitrogen for everything apart from carbonating beer. So that's pretty much like an 80 or an 85% reduction in CO2 usage itself. We do occasionally run out of nitrogen. If we were to do a 9,000 litre tank transfer, the very end of the tank we maybe switch it over to CO2 just because we used quite a large volume of nitrogen at that point. But for purging, exactly the same process that we would normally do. We just kind of do our blast purging and then we'll let it trickle purge overnight. Pretty much by the next day, it's as low as we need it to be in tank in terms of the oxygen remaining in there. What else do we do? Yeah, our canning line, we had a new canning line installed just after the nitrogen generator was installed as well, and that now fully runs on nitrogen instead of CO2. So purging of the cans and flushing under any lids is done with nitrogen, and the pickup we get is negligible. So our DO in can it is still under 30 on a good day. Majority of the time under 40, but so that's transfers, purging for tanks and for purging on cans, and we're still getting a very, very high quality product with no DO pickup, or negligible anyway. So I'm really happy with how we've managed to integrate it within our system, and it's been a good, fun experiment to do.
So in the pressures that you're using on canning line, etc., was that different to what you would have done with CO2?
So the fact that it was on site when they set it up, we have a microcan CP10, which is a counter pressure filler. They set that up with nitrogen in mind, so I believe there's maybe 1 bar difference in the pressure from CO2 to nitrogen. I think it just performs better with that. So it might be a slightly different head pressure on the small tank on the canning line itself, but the canning line installers were able to adjust that and set it up perfectly straight away. I think they use nitrogen on their canning lines as well, so they had some experience of that, and we had no problems with it.
Yeah, that's really interesting. I think if when I was working in the brewery, that would have been a concern. Is it going to be working, and the CO2 breakout as well, I guess, and it's always like, I don't know, you always feel it because it's not the same. So you've experienced any drop in CO2 levels in can after pack or anything?
Again, nothing noticeable. We'd probably lose 0.1 CO2 during packaging anyway, but it's not too dissimilar from using CO2, and we just carb accordingly. So like I said, the CO2, when we carbonate our beer, is the only time that we generally use CO2 in the building now.
So I know you mentioned when you're purging, you purge sort of a long and slow overnight, which is great and all. I always had a fear of doing that before with CO2 in case something started leaking and it was just spewing out CO2, which is obviously bad for everyone involved and also awful for the cost. Have you ever tried to purge a tank quickly with nitrogen? Like, let's say you had that morning, you had to get it done for that afternoon.
We haven't yet, but I mean, our bright tanks are slightly bigger than our fermenters anyway. It's something I'd be interested in trying, but I haven't tried it yet.
You're much better at production planning than I was then. There was a lot of panic purging, let me tell you.
Something for later in the year.
Yeah, so you were just going, and what sort of pressures, if you don't mind just going through that purging technique in just good detail, just I think so people can relate to what they're doing now to what
of course,
what it is with nitrogen.
So at the end of a peracetic acid rinse, we will get the tank up to about 7 psi, and we'll let all the nitrogen out the bottom valve to flush out any pez that's left in there, and then we'll get it up to 7.5 psi again and drop it out the top to get anything that's left in there, and then we'll get it up to around 1 bar, set the regulator on the nitrogen to about 1 bar, and then just feed in through the bottom valve and crack the CIP arm, so it's a very gentle flush through. And normally by the next morning, we'll do that last thing on the day, and normally by the next morning we're within our spec on oxygen in the tank.
And what is that spec, if you don't?
We try and get it under 0.5%. Lower's better, but anything under there is normally fine.
And you don't see a DO pickup at the end, I assume. Otherwise, they probably wouldn't have that spec.
I mean, trying to find a good figure, a good target is just you're just searching the internet trying to find what everyone else is doing. But we've not noticed anything as long as we're within that. I mean, even slightly higher, I think you're not going to have a huge amount of mixings with the gas when you transfer across anyway. But it's more of a kind of peace of mind thing. Yeah,
it's as much as the transfer technique as it is the DO in the tank, isn't it? I couldn't agree more with that. What's interesting is, do you see, because obviously now with nitrogen and you're purging everything, you're pushing your tanks out nitrogen, you no longer have to do the awful amount of venting of CO2 from a tank before you're cleaning, because you're cleaning with caustic, not with enzymes, right?
We're cleaning with caustic. I mean, we have looked at, because we're doing relatively hoppy beers, and it's rarely the same beer going into the bright tank. It's not something I've played around with in terms of just cleaning under pressure. But if we look at a centrifuge, which is something I would like to do this year, if we're coming out of a centrifuge with almost a bright beer, it's something that I would consider a little bit more, because there'll be less debris in there, and then just kind of rinse it out the best we can, and then put some acid in there for a quick clean, and then transfer into it again.
So you can clean almost the second you finished?
Essentially. I mean, we have gone in with the same beer again the next day and had no problems. But in terms of general cleaning, we've not done it under pressure yet, but you'd have no problems.
Yeah. And I mean, even if you're not doing it under pressure, because you're not venting it with, I mean, I've had places where we attach effectively an air blower to blow out all of the CO2, which now means your entire tank's replaced with air. So you've now got to, you're then using your CO2 to push that air out. Yeah. When actually, I guess, if you're not venting so much, there's actually very unlikely you've got much air in your tank to start off with. Definitely. So that helps to reduce the
you've pretty much done step one of your purge just by doing that. So if we were looking to purge faster, that would be an ideal place to start. I mean, that could save maybe a couple of hours by having it still full of nitrogen.
Did you find any issues when you switched from CO2 to nitrogen? Was there a bit of a teething period? Did you have to play with pressures or anything? Or was it quite... how was that process?
It wasn't too bad at all. I mean, we did a pretty good installation with our pipe work around the building, some drops with some secondary regulators at all the points we wanted, and to be honest, it's more convenient having that than running gas line from the other side of the building on a pack, and gas lines being everywhere. I mean, there were a couple of teething issues, and it's when we start transferring out of our larger tanks, so like a 9,000 litre tank, you probably, we pressurise our tanks up to maybe 1.5 bar when we're doing a pressure tank transfer on both of them, but trying to fill almost 9,000 litres worth of space with 1.5 bars worth of nitrogen, that's a lot of nitrogen.
Yeah.
It'd be a lot of CO2. So either way, you're saving your money because you're not spending it on CO2, which is then going to go out into the atmosphere anyway. But I think from that point of view, it's the limitation of our storage tank, which we can upgrade at any point. So what we've done currently is we'll get kind of 4/5 of the way through, and then if we need to, we'll just attach some CO2 and push that last bit out.
Yeah.
And apart from that, it's just trying to do too many things at the same time. But it would be exactly the same with a CO2 pack. I think if you try to keg, can, transfer, purge, all at the same time, I think you would struggle. So it's making sure that you don't do like a transfer, purge, and can at the same time, because you've also got head pressure on your tank that you're coming out of on your canning. So it's just prioritizing what you want to do and make sensible use of your resources.
Excellent. How did you? So what was your sort? I mean, maybe it's not comparable because you said you weren't canning before you got the nitrogen line, right? So I was going to try getting how much CO2 you were using before versus now.
I mean, we were canning on a smaller line, but that wasn't counter pressure filling. So I don't think that line was quite as thirsty for gas.
Yeah, almost certainly not.
I had been warned that the CP10, which is the one we have now, was thirsty on CO2.
Yeah.
And you would need to kind of go up from a 3/8 line to maybe a 1/2 inch CO2 line just to keep up on that. And based on experience on other canning lines like that, especially if you start running an inline carbonator, your packs just start freezing up. You have to have a heated regulator, which is expensive, and it just becomes another issue where it's all hard plumbed in now. And as I say, as long as the pressure doesn't drop below our target kind of purge pressure, it'll run all day.
So, Craig, in terms of cost per, I think we have to talk in meters cubed, right, rather than kilos, because I know I often talk in kilos for CO2, so I'll have to convert that to meters cubed. But what's the sort of cost difference? Because of course there's a cost associated with generating nitrogen. Maybe you can talk to us about that.
So the cost in the main for the nitrogen generation is just the electricity required to compress the air through some filters, through the generator, and the higher the purity requirement, the more compressed air required to produce that. So there's a ratio known as the air to nitrogen ratio, so it's how many more times. So if you need 10 metres cubed of nitrogen, you might need 30 metres cubed of compressed air to achieve that, just through the filtration process. So the measure of efficiency for a nitrogen generator is that air to nitrogen ratio. You want that as low as possible. And when we looked at, if we're taking those figures, we reduced the nitrogen generator system reduced the cost from £1.63 per metre cube for the CO2 bottle pack, and of course that incrementally increases every year, or maybe not so incrementally in certain years. And we got that from £1.63 down to 16 pence per metre cube, and that includes the annual maintenance of the equipment as well, so that's factored in there. It was at about 7.2 pence in terms of energy, and then just shy of 9 pence per metre cubed on the maintenance side.
That's incredible. Down from £1.60 to yeah, that's remarkable, really, including maintenance as well. I think I mentioned at the start, but one of the main things is that saving, or that cost is pretty much cemented outside of maybe some electricity spikes, but it's not going to go up 3,000% like CO2 is.
And the other thing is, of course, that as the world kind of recovers from the energy crisis somewhat, more breweries are looking at solar panels, etc. So if anything, the electricity cost across the industry, let's say, is coming down rather than up. And of course, the gas cost, as we mentioned, can incrementally have a 5% increase per year, for example. So the gap actually gets wider if you would take it over time.
Alex, did you have to get a new air compressor when you got the nitrogen generator?
No, so we had a reasonably sized air compressor already on site, and that was spec'd for our canning line, a keg washer, rinser, decal, pretty much every piece of equipment that we thought we could fit into the building at any time, even if we didn't actually need it. We spec'd our air compressor for that, and there was enough redundancy in that to allow us to run the nitrogen generator as fast as we want, really.
Is there an amount of compressor that you would say is recommended for? So I know it's kind of unit dependent, but for people listening who are thinking I'm already pretty close, or is it quite a heavy requirement for compressed air?
No, I mean, there's different ways of looking at it as well. We could, in theory, overnight, for example, charge up a nitrogen tank. You're using your compressor for canning and other things during the day, and you could use the downtime to have almost a nitrogen storage. But in terms of compressed air, I believe it's a 15 kilowatt compressor that Alex has got installed by our compressed air, the local distributor. So there was still about 50% of that was still available, and it keeps us well within the realm. So for a decent sized brewery such as Full Circle, you're still only talking 7 kilowatts. I think the perception is that it's, for small brewers, for argument's sake, is that nitrogen generation would require a huge amount of compressed air, a huge amount of electricity, and will be hugely expensive. But it's kind of, I think, as the range is developed, and the Pneumatech generator range is developed, we can suit breweries of all sizes.
Yeah, that's interesting. So yeah, other than electricity, and the maintenance, how much maintenance is required? Is it for let's say Alex's unit?
Yeah, so I think it's once a year, maybe twice a year. The compressor gets looked at anyway. So most people will have a maintenance contract with their existing compressed air system, so it pretty much ties in with that. It's not massively complex, as fortunately enough for me, but it's really just compressed air, a dryer, a few filters, so it's not heavily intensive on maintenance either. The generator itself tends to just be valves, etc. So the maintenance schedule for nitrogen generation, the majority of it is actually the compressor, which would be getting serviced on a regular basis anyway.
Excellent. I'm going to put you right on the spot here. How many times has it broken down, Alex?
I don't think the nitrogen generator is broken down.
He's not winking.
Yeah.
And I'm smiling.
Yeah. So Craig's got a sharp object and he's...
Air compressor went off once, but if your air compressor's not working, your nitrogen generator's not going to work.
Yeah, and neither's many other things, to be honest.
But apart from that, I've not had any issues with it.
Okay, that's great to know. And how long have you had the unit installed? I think you said earlier, but just to remind me.
You're probably looking at 5 months now?
It was a lot more than that. I think it was in
April?
Yeah.
It's now January. A few more than 5, eh?
Feels like a couple of months.
I think it's always good to talk about, it's kind of fairly obvious that the carbon footprint's going to be significantly better than purchasing CO2. Craig, do you want to go through that, or?
Yeah, I know that you'd got some figures for us, Chris, on the carbon intensity of purchasing too, and we have it at, I think it's 0.7373 kilograms per kilogram, which somewhat defies logic that a kilogram of CO2 has a lower carbon footprint than a kilogram of CO2. But looking at that and changing that to meters cubed, because the comparison wouldn't be fair if it was kilogram to kilogram, because of the density difference in nitrogen to CO2. So taking it to a common metric of a meter cube, It goes up to 1.338 to that decimal point.
Yeah,
And,
that's ludicrously inaccurate.
I'm not going to pick up on that extra decimal point. And to change that to, assuming a kind of average efficiency, decent efficiency of compressor, and 99.9% purity, we have that at about 6.8 grams. So it's a saving of, I think it's 94 point something percent.
Yeah. I mean, it comes as no surprise that generating nitrogen from the air is significantly better than purchasing CO2 from another country. Anecdotally, it's quite interesting because I had to ask my friend Ben at Zaviro why CO2 is less kilos of CO2e than 1 kilo of CO2, because it's kind of very counterintuitive. And the reason is it's a byproduct of fertilizer. So the way that they've calculated it is they've taken the total output or the spend of, or the sales of the fertilizer plant and divided it by the amount of CO2 they've sold. So that's why it comes out at that. So it's more of a tricky, it's slightly, I don't know, that's a bit of carbon accountancy for you. It's a bit, yeah, I mean, it's so deep and so complex that sometimes it can come across. It's why it's so funny that it's like to 5 decimal points. Because what I've just said is that the calculation is just like, well, the calculation's a little off. But yeah, I mean, it's fantastic, to be honest. I go back to saying that I don't think that anyone will be purchasing or should be purchasing CO2 in 5 to 10 years, and mainly for this kind of exact reason. It's such a significant difference. And even with carbon recapture, you're still all you're doing is taking that fermentation CO2 and reusing it down the line. So that is still an emission, which is one that you still have, but the nitrogen generation is so low at 6 grams. I mean, it's pretty it's not much considering what you do. Do you find you use a lot more of it now that it's more readily available? Because I remember CO2 is such a scarce resource in a brewery, and when it came expensive and in the short supply, everyone became like super anal about using it. Do you find it liberating and using quite a lot more nitrogen?
You just don't think about it.
Yeah, what a dream.
I mean, even the whole thing where you'd kind of, is the pack finished yet? Is there anything left? When can I get another one delivered? You don't have that issue, or you don't have to change a pack out halfway through a run and stop. It just continues providing, so that it does take a lot of stress off trying to keep raw materials and that kind of stuff coming in.
Mm-hmm.
Yeah, it's much, from my point of view, it feels a lot more consistent. I know what's going to happen week to week. I'm not waiting for deliveries to turn up. I'm not waiting to be told no CO2 is available for 2 or 3 weeks. I'm not waiting for the massive price rises. It's on site. And yeah, I mean, if we can find a way where I can save 10% of the CO2 I'm producing and use that to carbonate our beer and then use nitrogen for everything else, that would be the perfect blend for me, would be to have nitrogen for 80-90% of my production and then produce your own CO2 and recapture it and then use that just to carbonate the beer. That would be a really nice kind of ecosystem. Without having to kind of being off-grid. That would be wonderful.
Yeah, that would be good, wouldn't it? Off-grid.
Nice.
I love that. Have you ever thought about nitrogenating some of your beers? You've got such a bountiful supply.
I haven't. I mean,
Nitro Looper coming 2024.
Yeah, that's a special one. It's something would love to talk to more people about, because I know a lot of people have some experience in that. I just know the process is slightly different, and especially from a can point of view, I know that a lot more testing needs to be involved. And I think I saw Sean from Siren do a talk on it at BeerX, and it was really interesting, but it's from our small team, it's kind of a bit outside our scope at the moment. But if we could use it for that, it'd be amazing, especially on keg products. It's something I need to learn more about.
Sounds like there might be another episode of the Modern Brewer podcast coming soon. Is that you mentioned it earlier? You were talking about maybe needing a bigger tank. So, talking about maybe future-proofing the system. How did you go about speccing it? And does it sound like you're already at that full spec and you might need to upgrade, or how was that decision making and how has it panned out in reality?
So we did a kind of a theoretical study in terms of what we thought would be happening at the same time. So we kind of go maybe keg washing, canning line, and a little bit of head pressure. And it's all kind of spec'd around. What we do struggle with is when you start to add more things onto that, if you start to purge at the same time, if you start to do a transfer at the same time. So let's say you're doing 3, 4, 5 different things in the brewery using nitrogen, you use it up quicker than it can regenerate, which is where a larger storage tank comes in handy. So it'll fill up overnight, and as we use it during the day, most of the time it will stay at exactly the same pressure because we're not using any more than it can produce at that time. However, it was quite difficult to do a calculation for a very large tank transfer, and that does use a lot of pressure, a lot of nitrogen in one go. And I think a larger storage tank or a second storage tank, which is I think the cheapest part of the whole system, would kind of give us the buffer essentially to do more if we really needed to at the same time. Whereas at the moment we just manage it. I believe we have a 2,000 litre storage tank at present. Could have gone bigger to start with, but it was just trying to find the right cost, and it was still a bit of an experiment for us actually getting the nitrogen generator and see how much we could replace with everything. But I could stick another 2,000, another 3,000 litre tank in, and we'll have more than enough to work around that. And like I said, that's probably the cheapest part of the system, is a stainless steel pressure tank. And just put one in. We've got the plumbing already in there for an additional tank, and it's just a case of when we push the button on that.
Interesting.
And I think, sorry to interrupt you there, Chris, but I think it's important that when we discussed it in the first instance, we did have a plan to future-proof it. The tanks can be modularly added on over time, and then you can start refilling larger vessels overnight, etc., just to give you that, as you say, a little buffer for when it does take a large gulp, for want of a better phrase, in one go. The other thing, to go back to your earlier question, Chris, to Alex about is he using more than we first calculated? I checked the generator on the way in, and absolutely. I think we somewhat tentatively said changing about 50%, but it's great to see that it can do more. So I think we'd sized it for about 10,000 metres cubed per year, and I checked it there, we'll say 5 months ago, I think it was 9-ish, and it's consumed 19,000. So
it's awesome.
Excellent.
Yeah,
it would have all been CO2. So
nitrogen parties downstairs.
I guess the more you use, the more money you save. So pays for itself quicker.
Maybe we just we talked a lot about how great nitrogen generation is, but what are the limitations? What are the concerns if you are going to be generating your own nitrogen? I guess compared to the alternate would be maybe CO2 recapture or purchase CO2.
Yeah, maybe a little bit of footprint as you add on these tanks. Whilst they're not huge, I think we had this 1.2 by 1.2 metre area down there, so it's not as if we're talking huge, but as you add on another tank,
it's not big, is it?
And the immediate availability maybe would be better from CO2 and the high pressure packs. The electricity maybe for some brewers are already at maybe their peak electrical load. So those sorts of things, but it's different for every customer, of course. And if they're paying a great rate for their CO2 and they have a really high rate for their electricity, the savings will be the same for everybody. But the converse is also true, of course, that those that maybe aren't using as often or as much CO2 aren't getting a favourable rate. So even the smaller brewers can, as I say, sometimes the savings are higher per unit. For the smaller brewers because, as I say, they're not getting such a favourable rate from the gas suppliers.
And that is a perfect cameo into something I want to definitely ask is the accessibility of this technology. So, we've seen carbon recapture, for example, come down from what I think was about £500,000 to £250,000 minimum, and then it came down to maybe 16, it's probably gone back up to about 100,000 now, I would guess. Which is great because that makes it affordable enough for some breweries, but it's still not affordable on the smaller scale. So how accessible is this technology to smaller craft brewers? And maybe just quickly, contextually, we all love to talk in how much volume we produce, but just quickly, how much volume do you produce here, Alex?
So last year was about 6,000 hec.
6,000 hec. So Craig, what do you think? Is this technology available to the smaller than 6,000, for example?
Absolutely, it's a good question, and I think that is the perception in the industry, or it's the biggest kind of barrier that we find, is that the accessibility of the systems, or the perception of that is going to be that it's going to be too expensive, too much space, etc., etc. But to give you a recent example, there was a customer that was using 2.5 bottles of just singular cylinders, 2.5 roughly per week, and they could go for one of our smallest systems, which is under £10,000, including installation, including the pipe work, and they were saving £7,000 a year. So whilst the savings, they're big for large brewers, but it's absolutely something that's worth looking into as a smaller brewer, because that £7,000 is a lot to anyone, you know.
Yeah, absolutely. Yeah. Under £10,000 is accessible, definitely, compared to like 80, 60, 100 of the carbon recapture. Did you look at carbon recapture, Alex?
We did, yeah. So about the same time we went for this, we were looking at kind of both forms of technology, and the cost of the CO2 recapture at the time was relatively high, and there didn't seem to be a huge amount of experience in the UK brewing industry of that kind of product. I'm talking maybe 18 months ago. And I know it's probably changed since, but the cost of this project for the nitrogen was less than a quarter of what the CO2 recapture would be quoted on. And in terms of payback, we were looking between 18 and 20 months of usage before we made our money back on this.
That's
so
mad.
In terms of return on investment, it's a good option to look at. And I think it was kind of 4 to 5 years for the CO2 recapture. But that may change in the future, but that was kind of one of our key considerations, is try and be as sustainable as possible, but in an affordable way, which is key. If you can't afford to run a business, then what's the point?
Yeah.
We were chatting, Chris, on the way in. Obviously, we were discussing the other thing is your CO2 or your existing gas cost tends to be a monthly cost. It's an ongoing cost. If you were to take that £10,000 system over 5 years and save £35,000 in that time, monthly, it would be obviously monthly cash in your pocket up, as opposed to, so whilst and we're talking, and capex is something that's maybe a problem, or capital for brewers at the moment, just given the climate that we're in, for a lot of them anyway. If you were looking at monthly, and those options are available, you can rent one, or kind of lease purchase, or however you finance it, and you can save £500, in that case £600 a month.
So you can lease units or rent units from...
Yeah, I mean, all these options are available.
Across any size unit, or...
Yeah, we have finance company that we use, and they would do that.
That's awesome. Yeah, I mean, that makes it even more accessible, right? But this is what I'm saying, if I was to be, I know it's a lot easier when you're not, but if I was to be running a brewery, I'd be looking at my purchase CO2 and thinking, this is a cost that's got to go. I think we lived in a world for a long time where it was just something we did. It just came in, it was expensive, but it wasn't, wasn't top of the priority list. But I think with all these supply shocks, 3,000% increases, these weird contracts people are having to sign, it all just feels like it's time to move on, and if the technology is accessible, and for even the people who don't have the capital to spend, if there is an option for finance, it kind of must be a no-brainer, to be honest. To me anyway, it makes a lot of sense. If you're a brewer listening to this, Craig, how would they know how much nitrogen, what size nitrogen unit they're using, their cost savings after? I'm pretty sure I kind of seen it already, so I know you have a calculator, but maybe you want to talk through that, because I think it's really cool.
Yeah, on our website, we will have a link it in the comments or wherever we're putting it, but we have a brewery specific landing page, which has been brought together with previous webinars, etc., that we've done to try and make it a bit of a knowledge hub for brewers who are uncertain or don't necessarily want to get to that stage of speaking to anyone unless they know that it's going to work out. So within the calculator, we've tried to simplify as much as we can, and there's two options. So there's your existing consumption, so you put in, I think it's 3 or 4 cells, you put in, say that you're using 1 tonne per week, and that you want to change, let's say, convert 80% of that to nitrogen, so those are 2 of the cells that you fill in. You put in your existing supply cost, so £500 per tonne, or whatever your exact one is, and your electricity cost. So these are all things that you'd be able to find relatively quickly if you were looking at this, or you can use kind of averages, and it calculates your annual consumption and your annual cost, and then it calculates the potential savings and the CO2e reduction as well.
That's awesome. Yeah, and where is that calculator available?
So that's available on the Pneumatech website.
Okay, I'll link it in the notes.
Yeah.
So if you just send that over to me at the end, that'd be great.
So, Chris, the other side of that calculator, which I've just had, or we've just worked on, to be fair, is that you can put in your package consumption per year. Your package per year. So the number of hec, for example, and you can do it based on small, medium, large brewer, and it does the CO2 per kilogram calculation that you've shown in your reports, and it automatically assigns that, and it figures out roughly how much you'd be using and how much you could be saving. So even if you don't have the exacts of your CO2 consumption, how many tons, etc., if you know how many hectoliters a year you're brewing, we can get an educated guess, let's say.
Yeah, it's a really cool tool. I've looked at it and used some of my figures, which is pretty cool. But yeah, it makes a lot of sense. I mean, it's just easy to see what your ROI would be, where you're at. I think it's nice and accessible. Are you going to Beerex or anything, Craig?
Yeah, so we'll be at Beerex. In fact, we're going to put on an open morning because the office is in Warrington. So we're inviting brewers that are maybe travelling quite far to pop by the Warrington office. You'd be pretty much passing it anyway, where you can see an operational nitrogen generator, the membrane and the PSA in our, we call it our knowledge hub, so like a showroom, and we could talk to them about their requirements and things. I just think with Beerex being in Liverpool, as I say, a lot of these brewers will be driving past it in the morning, so for a few of us we'll throw in some bacon rolls. It's usually a good way to get people to promise breakfast.
Come with the bacon rolls, stay for the nitrogen generation. Yeah, okay, that's great. I mean, I'm going to also be at Beerex, so it should be a fun time. Are you going to Beerex, Alex?
Yeah, I'll probably be on a beer or two.
Yeah, of course. Otherwise, what's the point?
Yeah. First holiday of the year.
This is maybe... I don't have loads of scientific data to back this next question up, but it's a good discussion. So when discussing purity of nitrogen, I know a lot of people discuss the purity of the CO2 that they want, especially on recapture and, of course, on purchase as well. So what purity are you running to? 99.9, you said, Alex?
Yeah, so we're running to 99.9, which I think is pretty standard for that hardware. I think it can be dialed up further, but the higher you go, the more air and more energy you use. For us, I've seen no reason to try and increase that any higher. It's performing well. I say our final DO and can is normally under 30 or around 30. We're not seeing any pickup on our transfers, so I've got no reason to try and push that any further.
Craig, anecdotally, have you heard or seen of anyone using less pure nitrogen? Because presumably less pure nitrogen, as Alex just mentioned, is cheaper and you could probably spec your unit smaller.
Correct, yeah, absolutely. The 99.9 is where Alex is sitting, and it tends to be the kind of sweet spot we find for breweries. But of course, brewery to brewery is different. Some of them are running, I actually heard yesterday, something was running at 99.3 with no issues. 99.5 is kind of the except, but we tend to look at 99.9%, and then indeed, as you mentioned, Chris, if you dial it back in terms of purity, it's not a fixed purity machine. So if you just flow more out of it, it spends less time in the filters, and thus the purity decreases, so you can get more nitrogen out at a lower purity at a lower cost. So whilst Alex mentioned obviously not increasing the purity, if it's still acceptable, we would ask you, or we would speak to brewers about reducing it wherever possible. It could be further marginal gains, but it's all savings.
Yeah, that would be, I mean, this is again anecdotal, I guess, but it would be interesting if you dialed that down, Alex, and then maybe see if that worked. I don't know. It would be really cool to hear more about if that was possible. I don't know if you could do any tests on purging or something, but I think it'd be really fun for people to see if that, because imagine if you could turn that down and maybe, people could get a smaller unit, or I think it's just a cool idea. It'd be nice to experiment. Part 2 will be coming soon then. Craig, so obviously we've got some of the live case study right here with Alex, but have you installed any of the units across the UK, and how have they been?
Yeah, so we've got a few. I mean, in the brewing industry, there's only a couple. One down at Pressure Drop Brewing in London. They've got one of the membrane units, and they use it slightly differently to Alex. In the respect that Alex uses a more on-demand system, they utilise storage overnight. So they fill up larger tanks at higher pressure overnight, and then run off the tanks as a supplement during the day. It means that they could go for a smaller unit. Because the average flow, if you take it over a longer time, of course, is going to be less. So, as I say, they lean on tanks a little bit more and draw off that to supplement the flow Yeah, and there's a few more being installed in the next couple of months, so we're waiting them coming through. But out with the the brewery side of it, I know we're relatively new to the brewery side of it, but globally we have 600, 700 of these generators out there. It's not as if it's new technology to us, and in a lot of different industries, but the brewery specific ones we're kind of coming through just now.
Awesome. And Alex, what?
Yeah, just if anyone wants to come and see one working, so we're based in Newcastle in the northeast. I'm more than happy to show you around or to talk through what we looked at, why we spec'd what we did, and to kind of show you how it all works.
That's awesome. Yeah, I always think before any investment, going to see it working in real life and speaking to the people who do it, and talking to the people who are actually operating it and maintaining it is essential, because this is no offense to your profession, Craig, but there's a lot of great salesmen, great salespeople out there who are really good at telling you how great everything is. But see the real life examples, I think for me it would always be something I would look to do. It's essential, even more than just listen to this podcast. It's easy to talk, but it's better to go and see, I think. So I think that's a very generous offer.
So, it's not the most exciting thing to look at, but
I know,
it's a tank and a box next to it.
We were wondering if
you're more than welcome to come and have a look.
we were wondering if this is the first ever podcast on nitrogen generation. I might actually Google it to see if this is the world's first. But look, guys, thank you so much for coming on. I appreciate both of you are very busy, and thanks for hosting us here in the wonderful Full Circle Brewery. I really like it. So yeah, hopefully we'll grab a beer after this. And yeah, thank you so much for coming on, guys. Appreciate it.
Thank you.
Cheers. Well, once again, thank you to Craig and Alex for appearing. It was a really interesting episode. As I say, one of the ones I've really wanted to get done for a while. I'm certain that we need to get over this purchase CO2 habit that we have in the brewing industry. So I hope this helps you appreciate what the options are and how accessible they are. As always, please hit that follow, subscribe button. We're going to be doing an episode on carbon recapture, similar to this, with a test, with a real life example, and hopefully someone from a representative of a CO2 recapture company, so we can have a similar dynamic, because I think that worked really well. So hit subscribe or follow, don't miss an episode, and I will catch you on the next episode of the Modern Brewer Podcast.